Welcome to Spring LIB.
All right, so first we have light being reflected at the air alcohol surface here, and the phase change to that, the phi there, phi1 is therefore just pi due to reflection. Phi2 is a different story because not only do you have the additional path length traveled here, by the way, this is thickness t, the additional path length travel here, as well as the phase change due to reflection. So that is equal to 2t over lambda, lambda f1, because to signify wavelength in film for the first situation, times 2 pi plus pi, which is due to reflection. And so therefore the net phase change is phi2 minus phi1, and so that's 2t over lambda f1 times 2 pi plus pi, and that whole thing will be subtracted from pi. And so in this case, and so this is delta phi, and actually, let's call this lambda f, and not make it more confusing than it has to be. So delta phi, we're gonna set equal for constructive interference first. C will be equal to an integer multiple of pi. So this would be 2, let's call it m1 for order of the constructive wavelength of the constructive interference, 2m1 times pi, and that is equal to 2t over lambda f times 2t times 2 pi. All right, and so the 2 pi terms cancel, and what you get is t, in this case, is lambda f, which is lambda 1, okay, wavelength from constructive for constructive interference over lambda 1 over 2 times nf, nf being the refractive index of the film, times m1, okay? And in the case of destructive interference, for D here, delta phi, which is again 2t over lambda f times 2 pi, that in this case will be equal to 2m1, 2m2, signifying order for destructive interference, plus 1 times pi. So this is for destructive interference, and the pi's cancel. And again, and here you have t is equal to lambda 2 times 2m2 plus 1 over 4 times refractive index of film. All right, so therefore we set them equal to each other. We set the two thicknesses equal, and what we get is, so this is, the t is equal to lambda 2 over 4 nf times 2m2 plus 1. That is equal to lambda 1 times m1 over 2nf. All right, and so the nf's obviously cancel, and rearranging this equation on both sides, we're left with this ratio, 2m2 plus 1 over 2m1 is equal to lambda 1 over lambda 2. So this is lambda 1 is 635 nanometers, lambda 2 is 512 nanometers, and so this gives us 1.24. Note that this is approximately 1.25, which is 5 over 4. So the denominator is 4, meaning m1 is 2. The numerator is 5, meaning m2 is also 2. So therefore, m1 equals m2 equals 2. And so therefore, we finally have that t is equal to lambda 1, which is 635 nanometers, over 2 times n refractive index of 1.36 times 2, which is m, the order. And so T, the thickness, is 467 nanometers.